You flick a switch, and bam, the lights are on. We do it all the time without a second thought. But behind that simple little flick is an absolutely incredible, invisible journey that starts, sometimes, hundreds of miles away. So, let's dive in and follow the path.
Seriously, have you ever stopped to think about it? How does raw energy, made so far away, snake its way through this ridiculously complex maze to power our phones, our TVs, our entire lives? Well, that's exactly what we're going to trace in this explainer.
The answer, in short, is the electrical grid. It's one of the most amazing and maybe most underappreciated pieces of engineering on the planet. You can see the whole trip laid out here. It starts at those power plants, travels along those huge towers and lines, and finally ends up right at your house. It's this massive, interconnected system that's working nonstop 24/7 just for us.
All right, to really get this, we've got to zoom all the way out and start at the very beginning, with the big picture. We're talking about the absolute backbone of our electrified society, the power grid itself. So what is the grid exactly? Well, put simply, it's the whole shebang. It's everything from the moment electricity is created to the second it hits your outlet. You can break it down into a three-part story: making the power, moving the power, and then delivering the power. The whole journey kicks off right here, at the source. This is step one, generation. You've got huge power plants, nuclear, hydro dams using the force of water, thermal plants burning fuel, and they're all doing one thing: converting different kinds of energy into electricity. This is ground zero. Now, right away, we hit a huge problem: distance. You can't just send regular strength electricity hundreds of miles. It just fizzles out. So they have to ramp up the pressure. Think of it like a garden hose. To spray water across the yard, you crank up the pressure. With electricity, you crank up the voltage. And I mean, they crank it way up, to incredible levels, sometimes as high as 765,000 volts. That is just a staggering amount of power.
So this supercharged electricity hits the open road, or, the wire. This is step two, transmission. It travels along this superhighway of power lines, held up by those giant metal towers you see marching across the countryside. This is how power gets from the middle of nowhere to all the places where people actually live.
Okay, so the power has crossed the country. But here's the thing: 765,000 volts would literally vaporize your TV in a puff of smoke. So this next part of the journey is all about taming that beast and getting it ready for your neighborhood. As that high-voltage electricity gets to the edge of your town, it pulls into a local substation. This is step three, distribution. Here, giant transformers do the exact opposite of what happened back at the power plant. They step the voltage down, way, way down to a more manageable level so it can be sent out on the smaller, local power lines that run through your community. We're on the home stretch now. This is the final transformation, and it happens right on your street. You know that little gray can on the utility pole, or that green metal box in someone's yard? That's another, smaller transformer. It takes the power and steps it down one last time, to the 220 volts that can safely flow right into your house. The electricity has officially arrived at your front door, but its journey isn't quite over. Now it has to navigate the final few feet, traveling through the hidden pathways inside our walls to get to every single light and outlet. And this last step is all about safety. Obviously, you can't just have live wires dangling inside a wall. They need to be protected. And that protection comes from something called a conduit, which is really just a fancy word for a pipe that holds wires. The two main kinds you'll find today are either plastic or metal. Okay, let's talk about the plastic or synthetic resin ones first. Their biggest selling point? They are fantastic insulators. Since plastic doesn't conduct electricity, it acts as a great safety barrier, which really lowers the risk of electric shock. Plus, they're lightweight and flexible, so they're much easier for electricians to work with. And this is a perfect example of how they're used. During construction, they'll actually lay out all these plastic pipes and secure them in place before they pour the concrete for the walls and floors. The concrete then sets around them, creating these permanent, protected tunnels that are ready for the wires to be pulled through later. Pretty clever.
Now, on the other hand, you've got metal conduits, and their superpower is just pure toughness. Metal is incredibly durable. It protects wires from getting crushed or, say, if you accidentally drive a nail into the wall. It's also super fire resistant, which makes it the go-to choice for safety in all sorts of places, from regular homes to huge industrial factories.
You often see metal conduits like this in places where the wiring is left out in the open, like in a basement, a garage, or a workshop. Their strength and rigidity create this really secure, orderly pathway that keeps the wires inside safe and sound from the outside world.
So, there you have it. From a massive power plant all the way to the little pipes hidden inside our walls, we've traced the entire path. Let's just zoom back out one more time to appreciate the sheer scale of what we're talking about here.
So let's recap that incredible journey real quick. It starts with generation, creating the power. Then transmission, shipping it across the country at high voltage. Next is distribution, taming it and sending it to our neighborhoods. And finally, wiring, the last few feet safely through our walls. 4 huge stages, all working in perfect harmony.
It's honestly staggering when you think about it. Every time you charge your phone, you are plugging into a single, vast, continent-spanning machine. It's this one connected and almost completely invisible system that pretty much everything in our modern world depends on.
But here's a final thought to leave you with. This incredible system, it was designed and built for a different time. Today, our world is changing. We have new demands for renewable energy, for charging electric cars, for a grid that won't fail during extreme weather. So the big question is, how does this amazing, century-old journey have to change to power our future? What does the next evolution of this invisible network even look like?